Hi class. Today we're going to talk about compound inequalities. First, let's start with a little bit of review on just graphing a single inequality on a number line. So the first one says that x is greater than 3. So if I want to graph that on a number line, I'm going to put 3 on the number line, and then I'm going to count to the left like 2, 1, and then 2 to the right like 4, 5 of 3. Since it is greater than 3, 3 is not included in my solution set, so it's an open circle at 3. And then we go to the right with our shading because the numbers to the right of 3 on the number line satisfy the equation x is greater than 3. So remember, any value for x bigger than 3 would be a solution then. So x equals 3.5 would be a solution. X equals 15 would be a solution. Any x greater than 3, except for 3, because 3 is not equal to 3. So that's why we have the open circle. The next one here says x is less than or equal to negative 5. So if I put negative 5 right here, to the left we count down negative 6, negative 7. To the right we count up negative 4, negative 3, negative 2, negative 1, 0 would be right here. And then we'd get into the positives like 1, 2, 3, etc. So less than or equal to negative 5 would have a closed circle because negative 5 is a solution. Negative 5 is equal to. And then the numbers that are smaller than negative 5 are on the left side. So this time we'd go to the left. X is less than or equal to negative 5. You try the other two on your own for a warm-up. Then next we're going to talk about compound inequalities. Compound inequality consists of two distinct inequalities joined by the word and or the word or. And the graph contains an overlap of the graph of the two inequalities. And or the graph contains each graph of two inequalities. So let me show you what that looks like. First, we're going to look at inequalities with the word and. This first inequality right here, 3 is less than x less than 7, it is read as x is greater than 3 and less than 7. So it's read from the inside out. X is greater than 3 and x is less than 7. You can write it like this as well. X is greater than 3 and x is less than 7. The solution must both be greater than 3 and less than 7. Let's look at it on a number line. So I'm going to start by counting from 1. And I'm just going to count by ones up to, I think I'm going to go to 9. First, since it is greater than 3, we put an open circle at 3. It is not equal to 3, just greater than. And then it is less than 7, so I put an open circle at 7. And then numbers that are greater than 3 but less than 7 means that it is between 3 and 7. So I connect the two dots for the and compound inequality. So that all of these numbers between 3 and 7 would be solutions to this inequality. What is one solution to the inequality? X equals 5 could be a solution. But you could have 3.5, 6.9, any x value, all the x values between those 2 points would be solutions to that inequality, but not including 3 and 7. So we have the open circles. Okay. If you read this from left to right, it says that negative 2 is less than x and x is less than or equal to 5. If you read it from the middle, just reading this part, x, it's pointing to the negative 2 and it's like eating the x. So x is greater than negative 2 and x is less than or equal to 5. So if we read it from the inside out, it says that x is greater than negative 2 and x is less than or equal to 5. Max, come down here. It's my dog. I'm worried he's going to wake up the baby. All right, so I'm going to start, since we're starting at -2, I'm going to actually start my number line at -4. And then count -3, -2, -1, 0. And then 1, 2, 3, 4, 5, 6. At -2, it is just the greater than symbol. -2 is less than my x, so no equal to. So at -2, you're going to have an open circle. Then it's x is less than or equal to 5. Since it's also equal to 5, at 5, we're going to have a closed circle. So x values that are greater than -2 go to the right at -2, and less than or equal to 5 are less than to the left of 5. And so the numbers that satisfy this and inequality are between -2 and 5. Okay, this one. This one says we read from the inside out. So x is greater than or equal to 3. So from the inside out, we're pointing at the 3, so the 3 is the smaller one. X is greater than or equal to 3. And on the right, x is less than or equal to 12. Whoops. Less than or equal to 12. So I'm going to start this time with 0, and I'm going to count by 3 so that I can make sure to fit 3 and 12 on my number line. So it would be 3, 6, 9, 12, 15, 18. Since both of these have the line under the inequality, both of my circles will be closed. So a closed circle at 3 and a closed circle at 12. And all of the values for x that are greater than or equal to 3 and less than 12 are between. So greater than 3 and less than or equal to 12. So what is one solution to this inequality? You could say x equals 7. 7 is greater than or equal to 3 and less than or equal to 12. So any numbers between 3 and 12, including 3 and 12. 3 is also greater than or equal to 3, and 3 is less than 12. I forgot a solution for one up here. 0 could be a solution, anything between -2 and 5. X equals 5 is a solution, but x could not equal -2 since of the open circle in that example. So those are our and inequalities. We always go between the 2 points for an and. And is between 2 numbers. Or. Inequalities with the or. So this is read as x is less than 3 or x is greater than 7. So that means the solution must either be less than 3 or greater than 7. So if I want to graph this, I'm going to start with 2 and count by just ones up to a little bit bigger than 7. Go to 9. Okay, for an or problem, you graph each one separately. So for x less than 3, it's an open circle at 3, and the values that are less than 3 are to the left of 3. Then you graph the other one. X is greater than 7. So you put an open circle at 7, and you're going to the right. So x is less than 3 or x is greater than 7. A solution to this inequality, max, would be anything bigger than 7 or less than 3. So you could choose 2 or you could choose 9, etc. So the next one, this one says graph x is less than -3 or x is greater than or equal to 5. So this means that x is less than -3, or x is greater than or equal to 5. So I'm going to start with negative 4, but I'm going to count by 2. So it'd be negative 4, negative 2, 0, 2, 4, 6, 8. So then negative 3 would be right here, negative 3, and negative 5, or positive 5 would be between 4 and 6. X is less than negative 3 would have an open circle at negative 3, and the values that are lower than negative 3 are to the left. X is greater than or equal to 5. So x is greater than or equal to 5, I'd have a closed circle at 5 because it's also equal to, and then I would go to the right for all the values that are greater than 5. A solution to this inequality would be anything less than negative 3. So you could do negative 4, negative 3.5, and then or anything greater than 5, including 5. X equals 5 could be a solution. Or x equals 100 is greater than 5. So it's one or the other. Either it's less than negative 3 or it's greater than or equal to 5. We'll do one more. This one says x is less than or equal to 5 or x is greater than 10. So if we start, let's go with negative 5, and then actually we'll just start with 3 and just count up 4, 5, 6, 7, 8, 9, 10, 11. Yep, I can fit it. Just count by ones. So less than or equal to 5, there'd be a closed circle at 5, and we'd go to the left. 3, 4, those are all values that are less than or equal to 5. Or it can be greater than 10, so not equal to 10, so open circle, and then greater than would be to the right. So the and problems always go between the 2 points, and the or problems always face the opposite direction. One inequality solution would be x equals 4. 4 is less than or equal to 5 or greater than 10. So it's or one or the other. It just has to fit into one of the two. All right, try a few on your own and then submit it back to me.